Hi, in this lecture we are going to go over some of the questions from chapter 17, inference when sigma is unknown. So let's dive into first question, which is on the spider webs data, and the data summary is given to us with the mean value of 636, 634. Standard error is given to us, so this means that that's the mean. That is the standard error of mean 30 given to us for the web area of 15 females. So that means that 15 is nothing but sample size n. Assuming an approximately normal distribution, so we know one of our assumption is met here, and assuming that we can regard these 15 female orb spiders as simple random samples, so another assumption for this test is met. And we have been given a 95% confidence interval for web area mu in this population. We are give a 95%, so we have to basically calculate the 95% confidence interval in this case. We know any confidence interval is something around the mean, so mean plus minus margin of error, and in this case the margin of error is nothing but t critical value, because we know this is the t test because the sigma is not given to us, and times standard error of mean. Now we can also write it as sample standard deviation over square root of n, but we don't have to go that route because the direct standard error is given to us, so we can simply use this formula. So we can see that mean is known to us, standard error of mean is known to us. The only thing we do not know directly is the critical t value. But making use of two different pieces of information, we can certainly calculate this t value. So what two different information do we need? We are going to need degree of freedom, and another thing is confidence interval, how much confidence interval is, and then where we are going to make use of table in order to get that particular critical t value. So what do we have as a degree of freedom in this question? So we know degree of freedom is nothing but n minus 1, right? So in this case n is 15, so it's going to be n minus 1. So it's going to be 15 minus 1, and that's nothing but 14. So we know this one piece of information. The another piece of information is confidence interval, that's directly given to us. So they have asked us to calculate 95% confidence interval. So we know these two pieces of information. Then we look at table, and that's nothing but the table C, whatever you would like to call it as. So this is the t distribution table, table C. So what you're going to do is make sure you locate the degree of freedom first. So row for degree of freedom, you have to locate first. So we already calculated the degrees of freedom as 14. So that's why we are going to look at the degrees of freedom as 14. So we are going to look into this row until it meets 95% confidence interval. And we can see that this is the critical t value. So 2.145 is your critical value. So you just substitute that value. So therefore confidence interval becomes mean x bar, that is nothing but 364, plus minus critical t is 2 is 143 145 2.145 times standard error of mean, that's given to us directly as 30, So just substitute that value, and then you should be able to solve this problem by doing simple math. So you're going to have the two values because we know one time we are going to subtract, one time we are going to add. So let's see, 2.145 times 30, it's going to be 64, going to be 64.2.145, 64.35. So you're going to have two values from this. That's and if you solve that, you should be able to get it as these two values. So you know this is your lower boundary of confidence interval and this is your upper boundary of confidence interval. So you can write the final answer as your 95% confidence interval is having a range or the interval from lower boundary this much, comma, upper boundary of the interval as this much, and that's going to be your final answer. Alright, so now let's look at the next question. And the next question is pretty much theoretical, so we might want to read it very carefully. So it's based on some water diet. So water consumption before a meal has been shown to help reduce the calorie intake from that meal, but does it translate into actual weight loss? So does that um, gives us lower weight or does that lead to weight loss? That's what our question of interest is. An experimental, so this is actually the question of interest for the research purpose. That's not the question for solving this problem. An experiment randomly assigned overweight and obese individual age 15 to 75 years to one of the two diet groups. So we have two diet groups for total duration of 12 weeks. One group is a hypocaloric diet supplemented with 16 ounces of bottled water prior to each of the three daily meals, and that's what we call it as water group. So we have diet plus water, and that's nothing but water group. And then the second group is nothing but hypocaloric diet alone. So we are only giving some kind of diet, so that we call it as non-water group. Now first sub question, let's say what is it's asking. So each subject had his or her BMI computed before and after. So before and after 12 weeks of diet. So some kind of intervention, right? So in this case, it's a diet. For 23 subjects assigned to water group, the mean BMI before and after the treatment were this much, 32.16 and 29.5 respectively. Explain briefly why matched pair procedure must be used to assess whether the combination of hypocaloric diet. Now read carefully this particular last one statement. whether the combination of hypocaloric diet and pre-water intake significantly lowers the BMI. So basically, we are looking at focusing mainly on this particular group, right? So we know we have been already told that we are going to use the match pair t-test for this one, but we have to justify why. So here, all subjects provide two different data points. So basically, one data point is before taking that diet, and the second data point is after taking that particular diet plus water, that particular intervention, right? So we have two different data points, but it is based on the same individuals. So these data points acts as match pairs, right? Because these are from the same participants, but just at the two different time points. So that's why their BMI before and after diet for the same data point is provided for the two different data point for the same individual is given to us. Therefore, a matched pair t-test procedure would be required because these two data points, these are matched. These are matched because these are on based on the same individuals, right? So that is the justification for why we are going to use match pair procedure here. Now it will become more um, significant when we read the second part. So B part says 25 patients assigned to non-water group had mean BMI before and after. So this is also before and after 12 weeks diet, that BMI is 31.8 and 29.9 respectively. Explain briefly why we cannot use match pair procedure to test hypothesis that. Now this particular question is important. To test the hypothesis. Now in the previous question we were not testing the similar hypothesis, right? So let's see what is the hypothesis that we are going to test. So test the hypothesis that combination of hypocaloric diet and pre-meal water intake, so that's the first group, green one, is significantly better than the second group, and the second group is diet alone. So is it significantly better than the second group in lowering the BMI? So note that the question of interest is different than what we had in the A subgroup. So we have to justify here why we cannot perform the match pair t-test. And the reason is they are not exactly matched. So even though we are taking before and after data set, but if you look at the question of interest, it is comparing one particular group, that's the diet and water, with the other group, that is diet alone. So in both these groups, the subjects are different, so they are not matched, and that's why we cannot use the match t-test here. In fact, we will be using something called as two independent sample test. So it's based on two independent sample. One sample is in one group A and another sample is in group 2. So these two individuals, we don't know they are matched, right? And more than likely they are not matched unless it's in coincidence. So that's why we should not use match t-test here, and we should use something called as two independent sample test that we are going to look in the next chapter.